Welcome back everyone to this second session on environmental chemistry. Today I'll be talking on water contamination as well as conventional water treatment protocol. Okay. In the last session we talked about the hydrological cycle and the solvent properties of water, and I focused more on the solvent properties of water rather than the hydrological cycle and trying to explain how clouds were formed, etc., etc. Okay, because I thought there are students from different streams will be going through these sessions, so I wanted to make chemistry more easier and clearer to you rather than debate or discuss more on general issues like cloud formation. Earlier in this session also we'll be limiting our discussion on water contamination to the very minimum. Okay, rather we'll take more time on conventional water treatment systems. Okay, so let's begin with today's session. Okay, now basically when you talk about water contamination occurs when there is some foreign substance present in water, pure water or raw water, whatever it is. Okay, this foreign substance can come from any kind of source. Okay, and it has to exceed some permissible limit, okay, that has been specified, okay, for different parameters in water. And the sources of these foreign substances may be industries, it can be agricultural waste, it can be the pesticides, insecticides that are used in our agricultural industry, it can be domestic waste, it can be animal waste, okay, it can be microbes, it can be decaying matter, okay, it can be anything, and the source can vary from being a river, it can be a well, it can be deep borewell, underground water, okay, it can be a sea, it can be a spring water, whatever it is, whatever the source of water be. If it is contaminated with foreign substances that are beyond the permissible limits, okay, then we say the water is contaminated. Okay, now who gives this limits, who sets these limits to say whether water is safe or not? In India we have the Bureau of Indian Standards. Okay, they have set some permissible limits on certain parameters. So what are these parameters that we look for in water, okay, when we want to classify it as a safe drinking water, or sometimes we also call them as potable water? Okay, so there are different terms that we can use for it. Okay, we can call them safe drinking water, we can call them potable water. So what are the parameters? Parameters like physical parameters like color, odor, okay, pH, taste, okay, turbidity. This will be looked for. Okay. In addition to this, there will be other parameters like total dissolved solid, total suspended solids, total alkalinity, total hardness. Okay, it can be E. coli, microbes present, it can be total coliform count, okay, it can be an excess of heavy metals, okay, cadmium, mercury, whatever, okay, arsenic, lead, whatever, heavy metals. It can be something like persistent organic particles, okay, UPs, or it could be something like very simple terms, it could be insecticide residues, pesticide residues. Okay, it can be humic substances decaying from decaying matter. Okay, okay. So all these things will be looked for in water. Okay, before we classify them as safe drinking water. Okay, so if it falls in the standard, then it is safe drinking water. If it does not, then water needs to be treated. Okay, so for treating water, we usually have a basic water treatment system that has to be put into place. Okay. So what does this water treatment system look like? A water treatment system basically has a raw water tank. Okay? It basically has a raw water tank where the raw water is collected. The source can be anything, as I have already said. It can be anything. So from the raw water tank, the water is pumped into another tank, okay, with a big mechanical stirrer here. Okay. This tank is called the coagulation tank. This is called the coagulation. The raw water that comes in the coagulation tank has a lot of suspended solids in it. Okay, so these suspended solids are in the form of something called colloids. Okay, so we need to separate these suspended solids from the raw water. Okay. Now, there's a very special characteristic of these particles, the colloid particles. Okay, the colloid particles will look something like this with charges on them. Okay, why they have these kinds of charges, we are not going to go into much detail on this, but just remember they are somewhat charged particles with basically negative charges on them. So they are negatively charged, right? So since they are negatively charged, these particles will repel each other. Okay, they will repel each other. That is the reason why they do not settle in the bottom, they remain suspended. Okay, if these particles, because of gravity and their weight, want to come down and then settle down, the particles which are down there will repel them and again take them up. So there is a kind of stable suspension of these particulate matter. They are stabilized in suspension. So what do we do is, when we are going through this process of coagulation, what we do is we put in a material or a chemical compound called a coagulant. So we introduce a coagulant into the water. These coagulants are nothing but chemical compounds. This can be, the very common coagulant that we use is something called alum. Okay, this is the chemical compound we very frequently use. We call it, it goes by the name alum. There can be other substitutes for this. Ferric chloride, ferrous sulfate will come to it afterwards. So when we add this alum, the coagulant, what it does, it's a salt. When it goes to water, there is some kind of other kinds of chemicals present in water which gives it the hardness and the alkalinity that it possesses. Okay, so these are usually bicarbonates, carbonate salts, bicarbonates of calcium, magnesium, that is in there most of the time present in water, because it, as water comes along, it passes through different mineral deposits, maybe limestone, dolomite, deposits. Okay, so it takes these, okay, water dissolves them, takes in the calcium carbonate, the magnesium carbonate, the bicarbonates, and brings it along. So that results in the hardness, that results in the alkalinity associated with water. So let's consider that bicarbonates are present. So this aluminum sulfate will react with the bicarbonate. Okay, I'm not giving you the equation for it. Just remember, it reacts with the bicarbonate, okay, and gives you a compound called aluminum hydroxide. Ferric sulfate, ferric hydroxide, similarly. Okay. The characteristic of this is this will precipitate out. Meaning it is not soluble in water. So since aluminum hydroxide is not soluble in water, it will form precipitates here. Okay, so when the precipitates are formed, another important thing that it does is this aluminum comes with positive charges. So since the aluminum comes with positive charges, this will start interacting with the colloids. So when they interact with the colloids, positive charges, negative charges, okay, they will neutralize each other. They will start neutralizing each other. So when initially they were negatively charged and repelling each other, now after the colloidal charges are neutralized by aluminum, positive charges, what happens? We have neutral charges now. The total system becomes neutral in nature. Now there is no question of this repelling the other. So what happens? Now they will come together. Okay, they will come together, closer together, come in contact, grow, become a bigger particle. Okay, and that is what we call the formation of floc material. So once these particles, after the coagulant is added, okay, once it forms these kinds of particulate matter, it starts to grow in size. What does it result into? It results into the formation of floc. Now once this floc gets formed, bigger particles, once this floc gets formed, now the floc can come slowly down and easily settle down. So once this floc comes down and settles, it will bring along with it the suspended particles with it. So what happens? After some time, the liquid at the top, the water at the top becomes clearer as the floc starts to settle down. Okay, so this is what is called coagulation, the first process that we talked about. The first stage is coagulation. So coagulation is nothing but the addition of a chemical compound to water to destabilize the stable suspension of colloids. So once the floc is formed, there is one additional thing that I forgot to mention here. There is a big mechanical stirrer here, agitator. Okay, mechanically this thing is, the whole system, the water system is agitated slowly and slowly. Why is this agitation done? This agitation is done to increase floc formation. It helps in formation of bigger and bigger flocs. Okay, so the second process that we are talking about, flocculation, is nothing but this slow agitation to aggregate the flocs, to make it bigger, to make it a bigger settling floc. Okay, so that is what is known as flocculation. So coagulation and flocculation combined together is one of the best methods of removing what is known as turbidity from water. Okay, this turbidity cannot be removed by the other processes like sedimentation and filtration alone. We have to have this. Okay, and what is turbidity? Turbidity is nothing but, the presence of all suspended particles will give this water some hazy kind of appearance. Okay, when we remove turbidity from water, we will get a very clear, transparent liquid, water. Okay, so after this coagulation and flocculation process take place, much of the turbidity will be removed and clear water from this part is pumped out. Okay, so the coagulation and flocculation processes, you need to remember a few things. You need to remember what a coagulant is. Okay, examples like alum. There can be other examples: ferrous sulfate, one. Second, ferric sulfate, ferric chloride, sodium aluminate. There are different other chemicals that could be used as a substitute for alum, but it will depend, you have to remember, it will depend upon what kind of water you are getting treated. The water might come with a different pH. At times, alum works best between pH of 6 and 9. Okay, this might not work well between those pH. So you'll have to see what pH the water is coming, or what is the pH of water. Depending upon that, you will use different kinds of coagulants. Alum is preferred over others because it forms good flocks. Okay. Secondly, it, apart from reducing just the turbidity, it also reduces taste and odor from the water. Okay. Organic matter which imparts color and taste to water, those organic matter will again get absorbed on this flock and gets removed as it settles down. Okay, so you have water which is much clearer, much transparent, less odor, with less odor. Okay, so that water comes out and it has to be further treated. So what are the different stages now? After coagulation, flocculation, oh, I forgot to mention this. After coagulation and flocculation, the third step that is there is sedimentation. This is nothing but once the flock forms bigger particles, it settles down. We allow some time for it to happen. Once it settles down, once we get the supernatant liquid which is clear, we call that process as sedimentation. Okay, and the transparent liquid, whatever clearer liquid is up there, that passes, that is pumped to the other filtration systems. Now, the fourth process or stage is the filtration stage. What do we have over here? In filtration, we have different tanks again. Let's not put it like this. We have different tanks. Okay. Where we have a mesh here. On top of the mesh we have gravels, large gravels, smaller gravels, coarse sand and fine sand over here. That is what makes up the filtering unit. This filtering unit is called the pressurized sand filter, obviously because of the sand and gravel that's present there. So water inlet is here, water comes in, goes through the length and breadth of this filter bed, and then it comes out. Okay, maybe from this side, I'm taking it out from this side. Okay, it comes out from this side and it enters another unit, another tank which goes by the name ACF, which is short for activated carbon filter. As the name suggests, again we have activated carbon here, coarse, very small powdered carbon material, carbon powder. Okay, we call them activated carbon. What is activated carbon? It's nothing but the carbonaceous material heated to at around around 60 to 70 degrees Celsius. You get very fine powders, anaerobic conditions in the absence of oxygen. If you heat it, okay, it can be wood, it can come from wood, it can be wood charcoal, it can be coal, it can be, from coconut husks. Okay, if you burn them at very high temperatures, 600 to 700 degrees Celsius, you get carbon. The carbon is powdered, heated to 600 to 700 degrees Celsius at around in the absence of oxygen. Then what you get is activated carbon powder. So once you pass this water into the activated carbon filter, okay, once water goes in, this activated carbon filter removes color as well as other color containing, let's put it at color, okay? Color containing materials, makes water more colorless. Okay, it also acts on maybe some kinds of microbes also, and makes the water more pure. So that is the second stage of the filtration process. After the activated carbon, you have some more units here, okay, which are called micron filters. Water goes in, we have cartridges. Through the cartridges, water goes in and comes out, and then moves in like this from this filter inside out. Okay, moves into another housing, contains cartridges over here. Water goes into the cartridges, comes out. Okay, these cartridges are made up of, can be of polymeric material, it can be of paper, it can be of very high grade paper, can be of cloth material. Okay, whatever it is, the only important thing is that matters is the pore size of the material that you're using. It has to be of the micron size. Okay, the pore size has to be very, very small. So what happens, the water that gets in, okay, almost treated water goes in, and when it comes out, okay, even microbes, bacteria, whatever has not been treated, that has not been removed, can get removed here from these micron filters. Okay, one thing I forgot to mention, when this coagulation, after this process of coagulation, when the floc is settled and the water is pumped into the PSF, some floc material might remain suspended, that might go into the PSF. Okay, so PSF, when water passes through it, the floc materials will adhere to this, to the sand and gravel materials. Okay, so over a period of time, this becomes clogged. So you'll be needing high pressure to pass water through it. Okay, so in order to remove that clog, there's a system that is put into place. Okay, where this outlet and inlet of the treated water is blocked, and you have an inlet at the bottom from where water with a very high pressure is pushed into. So this is blocked. When water is pushed into, the water gushes out through this like this. Okay, so as it comes out, it carries the floc materials. It takes out the floc materials from the sand particles and the gravel particles, and that floc material is now thrown out from here into the drain. Okay, so this is how it is cleaned. The pressurized sand filter is cleaned. This process is called back flush or black flushing. Okay, so intermittently in between, the black flushing needs to be done in the pressurized sand filter to clear the floc material out of it. Okay, passes to the drain. So this is important here in this case. So after this, it goes to the active carbon filter, and then through this, the micron filters. Recently, they have added more things, many things here. You can have a reverse osmosis plant somewhere in between. You can have UV filtration, setup put somewhere here. Okay, but basically, the basic idea is this is what the water treatment system looks like. Start with the raw water tank. We have the coagulation tank, where coagulation, flocculation, sedimentation processes take place. After that, we have filtration tanks, where the filtration, proper filtration with different kinds of filters present. After that, you finally get treated water, and most of the time, the treated water that comes out will have parameters which are, you know, below the permissible limits as per the Bureau of Indian Standards. Okay, so this is how a water treatment system looks like. I hope you will be able to understand this. In the next session, we'll be talking about the dissolved oxygen, biochemical oxygen demand, and chemical oxygen demand as different water parameters. Okay, thank you.